So today, I'm going to talk about data quality. Data quality is probably our favorite subject as data practitioners, isn't it? We talk about it a lot, we think about it a lot. You're here today to hear about it again. And that's because we see the impact and the cost of poor data quality in our day-to-day work. So we understand the need to improve data quality. But many organizations, they're not really able to improve the quality of their data. They're mostly just working around poor quality data, and we're doing so at great expense and with poor outcomes. Today, I want to show you how we can prevent data quality issues at the source, because when it comes to data quality, prevention is better than the cure. So why is data quality important? Why are we here talking about it? Well, like I said, most of us understand why. We see it in our day-to-day work, and that's reflected in this survey from DBT, who found that 57% of data practitioners highlight data quality as one of their chief obstacles in preparing data for analysis. Probably not surprising. It's actually a problem that's getting worse because in the year before, when DBT ran the same survey, it was 41%. So it's gone from 41% to 57%. So it seems to be getting worse. And we probably see some of that in our day-to-day work. But on the other hand, it's not just us struggling with data. Business leaders also are not getting what they want from their data. There's another survey result. This one's they asked business leaders, so not data leaders, but business leaders. And they found that 64% of organizations think that data analytics are the way to deliver a competitive advantage, yet only 1 in 5 are using it to deliver increased revenue. And I find this one interesting because it just shows this huge gap, really, between the aspirations of leaders, what they think they should be able to achieve through their data, and reality of what they're actually seeing and how many or how few organizations are using it to deliver increased revenue. And I think these are related. I think a lot of this is down to how we deal with data and how we manage the quality of our data. Because working with poor quality data is difficult, it's time consuming, and it's expensive. And it gets more expensive the later you leave it. So Gartner have a stat for this. Gartner always have a stat for this. And they estimate that poor data quality costs organizations an average of $12.9 million a year. I don't know if that's true, but I think it's useful to be able to articulate the cost of this in some sort of way. Because if we can demonstrate the cost of it and how expensive data quality is and the impact it's having on us trying to derive value from data, then maybe we can get the resources, but actually more importantly, the alignment we need to improve the quality of our data at the source so we can deliver greater value for the organization. I think one way of doing this is to use this 1-10-100 rule of data quality, which you haven't heard of it before, looks a bit like this. And I'll go through all in a bit more detail in a minute, but what it's essentially saying is that the earlier you manage something, the cheaper it is. And that's almost a universal rule, I think. Like the obvious one is healthcare, which is probably where this came from. And clearly, it's better to prevent yourself getting sick. That's better for you, but it's also better and cheaper for the healthcare provider. So the healthcare provider tries to encourage us not to get sick in the first place. If we do, then it's better to get treated quickly and sort of locally in the community. If we have to be treated later in some hospitals, then it becomes more expensive for the healthcare provider and probably not so good for us either. So healthcare is the obvious example. Maybe an example a bit closer to where we work, a bit closer to our domain, would be software engineering. And you think about when you write software or when software engineers write software, we spend loads of time and effort trying to prevent bad quality code make its way into production. Things like unit testing, CI checks, code reviews, pairing, feature flags, all those all those processes, all those techniques are used to prevent the likelihood of bad quality code being deployed to production. And we do that because we know that once we have bugs in production, it's much more expensive to fix them. Obviously, we don't catch all bugs in code reviews or whatever else we're doing. So we still have bugs in production, and we still invest a lot in what we call remediation efforts, things like observability, alerting, incident management. It's still very important, but it's a lot cheaper if we catch it before it makes its way into production. So this rule applies to healthcare, to many things, applies to software engineering, can also apply to data quality, and in fact has been applied to data quality for well over 30 years now. So even though it's been around for a while, it's not that well known and still very applicable, I think, to how we can articulate the cost of poor quality data. So let's look at this in more detail when it applies to data quality. And what we'll do is we'll go bottom up through this pyramid, starting with failure. So when it comes to failure, this 1 to 100 model suggests that it costs $100 per record if we end up having data that is not usable, it's not accessible, maybe we just give up, we can't use it for what we hope to use it for. So then that $100 per record includes the opportunity cost, the fact that we could not deliver what we had promised, what we had hoped we would deliver. Maybe then the organization can't deliver on its strategic goals, it might perform more, more poorly in the marketplace, and therefore this $100 also includes the kind of strategic impact of the inability to use your data assets to deliver value. So this is where you're really doing nothing to try and manage quality of data. You're getting, I guess, garbage in and you're doing nothing with it, or you're unable to do anything with it. Now, the odds are, if you've joined this call today, you are probably not in this situation. You're probably trying to do something to manage data quality in your organization. And probably what you're doing is in this remediation space, which is where we do things like observability, testing, alerting, all those kind of things. And this is good. Certainly a lot better than nothing, but it's still quite costly. So although we can now notice issues quicker, hopefully recover from them quicker, often the issues still happen and they still impact users downstream, and the users still seeing that impact. Maybe we can recover in minutes or hours rather than days, but they're still seeing that impact. So it's still costly. Often when we find out about these issues as well, we're finding out about them in our ETL layer. And by that time, it's too late to fix it in the source. So we're implementing workarounds in our ETL. And that means that ETL becomes increasingly expensive, increasingly complex. That complexity will naturally lead to more issues because you have more logic in there that could potentially go wrong. So potentially you're having more data issues, despite the fact you are able to notice them more quicker through these mediation efforts. And if you keep having data issues, the problem is that users start to lose trust in the data. And once they lose trust in your data, it's very difficult to win that trust back. So mediation is good, certainly a lot better than nothing, but it's still a cost to it. It's still costly. What about prevention, where it's cheapest and most effective to deal with data quality issues? Well, I said many of us, we do a lot of remediation, we do less, or in some cases, nothing really about prevention. And a lot of things in prevention, they are harder to deal with, they're a bit more outside of control. Because we're talking here about things like shifting left so issues are caught up the source, which is what we do in software engineering. We shift things left, like testing and trying to catch issues earlier. Doing it with data often is difficult, but that's what we need to do to prevent issues at the source. If we can prevent these issues at the source, we can potentially prevent them occurring in the first place and having like no impact on downstream applications. That reduces the amount of data instances we have, which means we reduce we reduce those costs associated with instance, all that wasted hours firefighting and identifying the problem with the instance and the cost of running observability tools, all of that can be reduced if we can prevent these instances from happening in the first place. So, like I said, most of us do remediation, today I really want to focus on prevention and what we can do to prevent data quality issues before they happen at the source, where it's cheapest and most effective. So how do we do that? Well, if we take this pyramid and kind of overlay it on a simplified data platform, it would look like this. So failure, $100 per record, that's where it's impacting your ability to build these applications, or these applications performing so poorly they're not fit for purpose due to the quality of the data. Remediation, $10 per record, that's around the data pipelines, observability, the ETL, the checks we put in there. Prevention, that's at the source, preventing these issues from happening in the first place. But how do we do that? How do we prevent data quality issues at the source? And maybe a big question is, how do we incentivize data producers to put more effort and more discipline into the production of data in the same way they do into their software? But it's tricky, but there are ways to do this. And I think to illustrate how we can do that, I want to look through a practical example of a data quality issue and share that with you. And the one I want to go through is upstream breaking schema changes. And the reason why I chose this one is because this was the most common where I worked, and it's what led to us eventually adopting data contracts. And I think it's common for many people. And this means where, like a column changed upstream, it was being populated, now it's no longer being populated, or it's been removed, and it impacts everything downstream. So those kind of breaking changes to the schemas upstream, these are the kind of issues I'm talking about. But really, these are preventable data issues. There's no technical reason why they should have such a wide impact they do currently for many of us. So I believe these are preventable, but how? Again, how do we prevent these issues? Well, before we can think about how to prevent these issues, we need a deep understanding of what is causing them. What's the root cause of these incidents? Why are they having this wide impact on our data applications? And the way to identify those root causes is to perform a root cause analysis. Now, root cause analysis, they are done in many industries, construction, manufacturing. Whenever anything goes wrong, you basically try and understand why it went wrong, and you look at everything that might have contributed to that incident. And there's a few techniques to do this. One of the most popular is called 5 whys. Basically, you ask why and keep asking why until you identify the root causes, until you exhaust all the potential causes. What I'm going to show today is a slightly different one, and it's called a fishbone diagram. And it looks like this. So I'm going to go through this in more detail in a minute, so don't worry about trying to read all the text in it, because it might be quite small on your screen. But the way it works, and well, the reason why it's called a fishbone diagram is because if you draw a couple of lines around it, it looks a bit like a fish, which is one of the reasons why it's my favorite, but not the only one. It's actually really useful to perform this analysis. And the way it works is in the head of a fish on the right, you have the issue you're trying to diagnose to identify root causes for. So in this example, it's upstream breaking schema changes. Then could be the bones coming off the spine, if you like. They are all contributing causes to that issue. And you might group them by certain areas and have more bones coming off it, more causes coming off it. And you keep adding as many of these lines as you like until you've identified all potential causes or contributing causes to this issue, adding as much detail as you need. So it's quite nice. A bit like 5 whys, where you keep asking why, but this one you just keep going keep adding more lines until you completely exhaust all the contributing factors to this particular issue that you're looking at. So that's how a fishbone diagram works. And I've created this to look through what are the root causes for an upstream breaking schema change. So let's go through some of these in a bit more detail and look at what the causes are and then what we can do to prevent this issue from happening. We'll start with people. I think that's always a good place to start because often processes and technology and architecture reflect how people are working. So that's good to start there, I think. And here we got things like responsibility, like ownership, shared ownership, which is, as you probably know, basically no ownership. Um, Collaboration, org structure is probably something we can't change overnight, and but it's still a contributing factor. The way organizations are laid out does contribute to communication and ownership issues and responsibility issues. So still worth looking at those, even though we can't directly address them properly. Got things like visibility, incentives, um, awareness. Some of those are things we can do better at, and are things that we can potentially impact from our place in our data teams. So there are some things in here we can change, some things in here we can't change or can't change uh, quickly. It's going to be a long change. I think probably the most important ones of this particular issue are responsibility and ownership. So let's look at those next and think about who's actually responsible for the quality of the source data. Well, if we go back to that simplified data platform, this is kind of where responsibility should lie. Might not currently in your organization, but where I think it should. And what I'm saying here is that often if you're in a sort of technology company, a product company, then and your data coming from both systems, then product engineering should be responsible for that source data. Now, they may not feel like it today, but if you think about it, they're the ones who can impact the quality of the data, so therefore they must be responsible for it. Right? Like, say the issue was timeliness. Well, we can't make it more timely downstream. That can only be fixed upstream. What if the issue was completeness of data? Well, again, we can't make it more complete in our ETL layer. Maybe I infer it, but it's not quite the same. You can only fix that with source data. Similarly, with upstream schemas, we can't fix those in our pipelines. You can only mask them, but you're really taking a lot of work there. To fix those, you have to fix them in the source data and manage those schemas correctly. So if only they have the ability to improve the quality of our data, then they must be responsible for it. But how do we move that responsibility left to the product engineering teams? Well, the question is, why would they want to take on responsibility? Like, they're busy, they've got loads to do. Why would they want to take on responsibility? But only do so or be incentivized to do so if they understand the value. And they don't currently understand the value of what we are doing with data because they are so far away from where the data is actually turned into value. And there's so little collaboration between those using the data and those producing the data. You see, there's a big gap between where the data is generated and where it's being used. The team is in the middle of this, in between these teams, like a layer of indirection. So if they don't understand how data is being put to value, why would they value the data in the same way that you do? Like they wouldn't. So somehow we need to encourage collaboration. We bring these two areas closer together. And to do that, it's quite a lot of work for us, I think. I think we really need to be very good at articulating the value of our data-driven applications. We need to explain why it's important for business, how it helps business achieve its goals. And if we can do that, and if we can do it well, I don't see any reason why we can't incentivize data producers to provide better quality data that meets our requirements. In this case, data that doesn't change overnight, breaking our applications and breaking the applications for our users or our customers. So it starts with communication, I think, and collaboration. And it starts with addressing the issues in the sort of people area, the cultural issues that we have in our organizations around how we view data and how we view responsibility. Other areas you might want to look at are change management and the tools and systems that we use to move data around. And these are related, really, which is why I put them together, because You need to agree that change management is important, and then you need the tools and systems to implement that change management. Again, looking through some of the causes here, a lot of it is communication again, a lot of it is collaboration, a lot of it is lack of knowledge and lack of visibility. So still very related to what you just spoke about in terms of those people changes we need to make. But once we have agreed that change management is important and we have the people kind of lined up and agree that this is a thing we need to address as a company, and if anything, think about how we implement that in tooling. And it's actually quite tricky due to the way that we typically move data around, which is by using things like change data capture and ELT to grab data from databases. Because what we're doing here is we're building directly on the database, the same internal models that the source system is using. And those models are not really made for consumption, they're made to satisfy the needs of its service. And they should be changing quite regularly. In a high performing product engineering organization, they are changing regularly. And that should be expected. They need to change to deliver features, to improve performance, whatever it is they need to do in product engineering. That should be expected to change quite regularly. And yet, when they do change, it's us that are caught out by it, and our applications that break, and our time spent quickly changing our ETL to match those changes. So, why is that the case? Well, I think the reason why is because we're building on those internal models rather than building on top of an interface between those models and our applications, our pipelines. So I think we need to do better here. We need to have interfaces between those systems. And interfaces are a very simple idea. You see them everywhere in software engineering. So imagine using a Python library that's got a public interface, those methods you're calling. And the version, if that public interface won't change between minor versions, and one day there might be a big change needed, there'll be a new major version, and there's some migration path from that minor version to that major version. And that allows you to use that library in your production code confidently without knowing that you have to keep changing it every time you do a deployment. So we see interfaces in software engineering in libraries. Another example of an interface would be an API. So the I is
No
application
sé.
programming interface. That's another example of interface where it's often used internally between systems and also externally between companies. And again, you've got this stable interface you can build on that is not going to change. If it does change in future, there'll be some sort of migration path to that new API version. So we see them everywhere where there's this sort of producer consumer dependency. We don't see it so often in data. And I think that's one of our problems, one of our root causes to why data quality is not addressed upstream, is because there's no interface between the upstream data and downstream applications. So I think we need to move towards a world where we use interfaces for that communication. We can use those interfaces to assign greater responsibility, to enable more collaboration, and most importantly, to allow things to change on one side, say the database in resource systems, and not like everything downstream. And that is the problem that's root cause of most of our schema issues that we're having. So we use interfaces. What can we use for an interface? We can use a data contract for this interface. So I'm not going to spend too much time on what data contracts are, only in context of this. The definition I wrote in my book is this, and the words highlighted are interface. Again, I love talking about interfaces. Data contract agreed interface between producers and consumers, sets expectations around data, defines how it should be governed, and facilitates explicit generation of quality data that meets requirements. Now today, because I'm focusing on particular root cause of breaking schema changes of data quality issues, when we talk about interfaces and explicit generation of data. But there's more state contracts that we can look at another day if you like. So really we talk about interfaces here. And the way to simplify that definition would be just think of data contracts as the API for data. It allows us to produce these interfaces that are stable, still evolve over time. Data does evolve over time, but should be fairly stable. And often when people talk about APIs, they refer to it as a contract between producer and consumer. That's why we call it data contract, because it's the same sort of thing. And just to briefly look at what it might look like, it's basically a schema and metadata. Here I've defined in YAML, doesn't have to be YAML, could be JSON, could be code, whatever you like. But it should be a document that is human and machine readable and should contain a few important things in there. Owner, we should always have data that's owned. A version. So I just talked a lot about interfaces and change management. If you want to implement change management on the interface, you need to have a version number. All APIs have versions, all libraries have versions. Data contracts also have versions. And the schema, which is defined in code. And the schema is useful, we'll see in a minute, to implement the change management on the actual schema, on the actual interface, as we'll see in a second. So very quick run through of what a data contract might look like. What's more important for this talk is how we can use that document, that human machine readable document, to apply change management to our schemas and prevent these schema changes from happening. So let's look at that in a little bit of detail. There's really 4 steps to this. First, we have this document we can talk through, which helps encourage collaboration between producers and consumers of data. They collaborate on this document, like a requirements document or an RFC or whatever else you might use in your organization. And you capture the requirements here, you discuss it here, and then you kind of codify what you've agreed. So have you agreed, for example, that there's going to be a particular SLO or particular shape, schema, or whatever it might be. And like I mentioned earlier, it's really on us as data people to provide the incentives here. What's our requirements? Why is it important? What's the value? What's the ROI? Things like that. And if we can do that and do it well, then the producer takes responsibility for things they need to be responsible for: quality, change management, interfaces, etc. So really a document here, like any document we use in organizations to capture requirements and codify what's been agreed. Next, we apply change management to this document. So this could be in a Git repository, which would be for my use case here. I'm talking about software engineers and the changes they're making. Git would be a natural choice. If you're talking about other systems, maybe third-party systems, maybe the best place to apply change management with, for example, web UI or something like that. But whatever it is, you need to have some change management here, and you need to be able to increment versions when they're breaking changes to this agreement. We then create the interface from this document. So this is why it's important it's machine readable. And by interface here for data, that's normally like a Kafka topic or a streaming application, stream platform topic, or a BigQuery table or a table in your data warehouse, something like that. So we create that interface from the data contract through code. And the reason we do that is because we have change management on the contract. By extension, we now have change management on the interface, and they will stay in sync and provide us the change management we need to ensure that the schema does not change without change management being applied. And finally, we encourage or we change our services so publish data to this interface, moving away from sucking data out of databases through ELT and change data capture and the like. So we end up with an architecture that looks a bit more like this than the one I showed earlier. Data producers define the data contract in collaboration with consumers of data, apply change management to that contract, provision the interface from that contract, generate data and publish it to the interface, and that's what we consume from. So now that interface providing clear separation between consumption and production. And you have change management on the interface. So that's just one example of how we can use a data contract to try and prevent these breaking schema changes happening upstream and affecting things downstream by applying change management to those schemas and by changing our architecture so that we are using interfaces rather than sucking data out of upstream systems. But there are many others that I haven't had time to talk through today. I did kind of show briefly in the data contract actually in the YAML file, you have data quality rules in there. You can run them regularly and send alerts to data producers. It's probably more in remediation, depending on where you run those rules, but you can do that through data contract. You can implement and monitor SLOs. So you can start to monitor the quality of the data through the data contract. You also use data contract to automate various governance tasks, data retention, access controls, not necessarily data quality, or at least not in terms of how it impacts our downstream systems typically, but still very important for management of data and still important if we're going to try and shift things left. You need to provide those kind of tooling. So just one example I wanted to run through today was the schema changes. What I'd encourage you all to do though is think about what's the most pressing issue for your data team today. Are you constantly dealing with schema changes? In which case, hopefully this has been useful and you can apply some of these learnings directly to your organization. Is it maybe semantic changes that always cause you problems? Maybe that's more data quality rules and think about how to implement those at the source. Whatever it is, well, think about what problems you have and then doing a similar exercise, perform that root cause analysis. What are the contributing factors to the problem that my data team is facing? That's taking up all of my time, all of our time. Do that root cause analysis, get people involved in business as part of the root cause analysis, really understand why it's happening, and then think about how you can prevent these problems from happening in the first place at the source, because that is the cheapest and most effective place to deal with them. Because data, like data quality, like with many things, when it comes to data quality, prevention is better than the cure. Thank you.
Thank you very much, Andrew. That was great. Just thought I'd ask a question actually whilst I thought about it. So I appreciate the presentation isn't solely about data contracts, but in terms of as a as a data engineer myself, I'm always interested in tooling and things like that. Apart from DBT, which personally I think has implemented data contracts quite well. I don't know if you have an opinion on that, but have you seen any other tools that are starting to really think about implementing data contracts properly?
Yeah, it's a good question. I think it's still quite early in the tooling stage, and there's different ideas about what data contracts are and
Absolutely.
different tools implement them in different ways. So you mentioned DBT, for example, has become one implementation, which is basically trying to prevent you from change that schema.
Mhm.
Confluent and Kafka, they have kind of a different implementation as well, which is basically around schema management with a schema registry in Kafka and there's other tooling in the Confluent platform. You mentioned Chad Anderson's coming on here soon, so
Yes.
he'll talk about his platform, which he's building. I'm sure he'll mention it.
Yes.
Ray, so yeah, there's kind of different opinions on it, different approaches to it. The data contract platform I described when I wrote about my book, we built that in-house, but it wasn't much work really. It's basically configuration around, in our case, Google Cloud and infrastructure as code, existing infrastructure as code platform. It's really more of a pattern that you can implement in your data platform rather than a tool you build and deploy, I think. So even like DBT, that's a pattern they've implemented to try and handle schema changes. We try to take that further left and apply that same pattern to schemas or to the interface that data comes through, which in our case was PubSub and BigQuery, but could be Kafka and Snowflake. It doesn't really matter. So I think it's more about the pattern you can apply to your organization through tools you already have. That's probably where it's most interesting to use data contracts.
Yeah, no, that's a really great answer. Thank you. And I suppose on the tooling point, as you mentioned, it's tooling is only If you go with the classic triangle, one third of the battle, right? So the pattern is the thing. The tool implements the pattern, but the people and the processes also have to implement that same mindset and pattern.
Yes, exactly.
Yeah. Cool. Okay. Oh, well, looks like we have a question. Two. Great. Thank you, guys. Lewis, if data producers are not data teams but business users, for example, dumping data in a Google Sheet or Excel, where we've all seen it, um, with
Yes.
issues in naming conventions, any suggestions for these types of data producers?
Yeah, it's a good question. I get asked this kind of thing quite a lot because I tend to focus more on software engineering teams because that's where I applied it first. But we do apply again, it's kind of similar to what we were just talking about, these kind of patterns. How do you apply the same patterns to those data producers, to those systems they're using? So with Google Sheets it's a bit difficult, I guess, but let's imagine um you agree on some sort of structure for Google Sheet. I mean, you prevent them from changing that Google. I'm not sure if Google Sheet's the best solution to be using for this, but like maybe I'll give you a better example, which would be an easy example for me to articulate, which would be something like Salesforce, where again, the business users own Salesforce and administer Salesforce and use Salesforce. There's no place to put code there. What you do there is you have some way to capture the agreement between the Salesforce admins and the data teams or consumers of data. And that probably won't be a YAML file. It probably will be some sort of table, some sort of web UI, could be Google Sheet. And then you think about how to build maybe tooling, not quite as left as we would like, because you can't put code in Google Sheets or Salesforce, but as close you can as possible. And then when you have a data quality issue, so maybe the naming convention they've used doesn't match what they said it would in data contract, you can have a root alert to them, maybe send them an email. So they are responsible for fixing that. And they get that kind of sense of ownership. Like it's my Google Sheet, or it's my Salesforce instance, and I I'll get the alert now. I have to go and fix it. I'm feeling with pain. So next time take a bit more care. Or if I'm very good at Google Sheets, I'll add more validation in Google Sheets or whatever it might be. So really, again, apply that same sort of pattern, moving things a bit left, assign responsibility and ownership to them. In this case, it's less about interfaces, more about those alerting and sending the alerts or making them feel the pain, as it were, so they can take ownership of fixing the data, not you taking ownership of identifying the issues and going to tell them to fix the data. I'm automating that change management and bringing that loop a bit closer. So yeah, that's the kind of approach I would take. Apply the same pattern, but modify it based on the limitations we have in that particular example.
Thank you, Jenny. I think that's a really good answer. Just to add to that, actually, if I may, it is as data contracts tie into issues of data quality, and I think you kind of said this just now. Data observability as well. There's almost no point in you can't track data quality issues without having some observation on it, without having alerts that there are issues in the first place, without having someone looking out for them, right? So yeah, the observability comes into it, and if you've got a team who owns the source data, who isn't particularly helpful in doing that and facilitating the data quality issues you have, then yeah, as you say, Andrew, it's all about alerting and making them aware of it, and making them take ownership of it. You have to be not exactly heavy handed, but you have to put it in their court.
Yeah, exactly. Because I think what a lot of data teams do is in this problem, like we get data from a Google Sheet and it's landing in a data warehouse and there's issues with it, like a naming issue. What a lot of data teams do is they just change the ETL to say, coalesce those fields together.
Mm-hmm.
And what you're doing there, you're doing nothing to improve quality of data there. You're working around it, which is kind of what I mentioned earlier. Whereas if you then, rather than just fixing it, you go back to the data producers and this time business users and say, hey, look, that broke everything and you need to fix this and this is why it's important and this is the issue you had on with our stream and it's taken us all day to fix it. You articulate problem and value from it and provide them right tooling or at least right alerting or whatever it might be so they can take ownership of these problems, then you're still moving a bit more towards that prevention layer in the pyramid rather than just remediation, just working around things. So some of the tools you already have, observability is important, but how you use them as well can impact the effectiveness of that tooling and how it's improving data quality earlier rather than later.
Absolutely. Thank you. Okay. There's another question here. So I'm really sorry if I get this name wrong. Ajith. Hi, Andrew. Thank you for your talk. Quick question. How does data contract allow for contextual rules? Example, the same schema can support multiple products in our org, but the data quality rules can be different for different products.
Well, that's a really good question. I think it's actually why it's difficult, I think, to go and buy a data contract solution and plug it into your org because a lot of it is it's contextual. It's how do you want to apply data contracts to your organization's data in the way it makes sense for your particular organization. Because although we have similar problems, it's all a bit different. All organizations are different in these kind of subtle ways. So in this case, it really depends how you implement it. But if I was going to do this, what I'll do is probably some sort of inheritance in data contracts. So you have some sort of base data contract, and then you have specific versions of it or specific instances of it that imply different rules, but ensure that you're using the same sort of semantics, same ideas, whatever it is that you want consistent across the different multiple products. Um, so I've seen a few things a bit like this. People have created like libraries where they can, kind of import data contracts, and it kind of gives you the first half and you do the other half. We do a bit of this similar actually where I work. If you're using a particular source of data, it will automatically add certain metadata for you and make that part of data contract. And it has to be there, or it won't be, data won't be able to be published. So try and enforce some of those rules there for similar data sources. That's more of a data source side, but you're talking about products, which I think is quite similar. It's more of the representation of data. So yeah, these kind of there's nothing in data contracts where you couldn't do this. It's just how you apply this pattern to your particular use case. And in this particular use case, I'll be thinking about some sort of inheritance or some sort of mixing or some way to, because I think what the goal here is probably to enhance a bit of standardization across the different products while still allowing to be specific in certain ways. And that's how I do it through some sort of inheritance or mixing pattern applied to data contracts.
Cool. Thank you. Yeah, no, I think that makes perfect sense. It's there's a lot that the data world can still learn from the software world, but it's getting there for sure. And mix-ins and inheritance are definitely one of them.
Yeah, I hope it makes sense. Yeah, I've got a software engineering background, so I do kind of fall back on that quite a lot. But
No, I appreciate that personally.
if anything makes sense, actually, then feel free to follow up or find me on LinkedIn or email me or something. Happy to go in more detail, but hopefully it makes sense.
I will add to that as well. Actually, sorry, this is a topic that I find really interesting. It's with the whole inheritance thing, you can get into this kind of. I can foresee in some organizations getting into a kind of situation where someone goes, "Oh, I don't quite like that data contract. I'll modify it for my own needs," and then the next person does it, and suddenly you have 6 versions of the truth, which is it's just kind of it comes into the whole process and people side of things again, where you have to have things in place to stop people because it could get out of hand quite quickly. I'm sure. I don't
Yeah,
know if you have any thoughts on that.
but yeah, I agree. So, I mean, yeah, and like if you try and make it too constrained, people will find workarounds. Humans are very good at escaping from the kind of guardrails you put around them if they don't feel it makes sense for them, or if you have too much friction, they just won't use data contracts at all. So always a balance in terms of the level of customization you're allowing, the guardrails you put around them, the friction you add in. Some friction you add on purpose, like change management, but friction you add in where there's not as much benefit. If it adds up too much, we're not going to use it. So you're constantly balancing you're making these trade-offs, which is what you're doing whenever you're building a platform. So my background is in platforms and just more recently, I suppose, data platforms. And it's always a balance you're making, always a trade-off you're making. And again, there's no one answer for every organization in every context, which is why I think it's difficult to buy a data contracts tool and deploy it. Um, you have to think about people in your organization process, your current maturity, where you want to take it, and apply the patterns as best you can to move something forward in your organization.
No, no, exactly. Great, thank you so much. That's all of the questions at the moment. I'm sure if anyone has any questions, then as you said, Andrew, reach out to you on LinkedIn. And of course, when this goes up on YouTube, feel free to leave a comment in the on the YouTube, and either way, will facilitate answering that, or we'll leave it up to you, Andrew, if you want to do that. Okay, well, thanks so much. Is there anything else you want to add before we call it a day?
No, yeah, that's great. Thanks everyone for joining me. Yeah, I've got I did a little free white paper if you want to learn a bit more data contracts in general. So feel free to download that. That will optionally add you to my main list as too. I'll do a weekly email, so feel free to join that as well. Um, and feel free, yeah, if you've got more questions, feedback, I'd love to hear from you. So feel free to email me, reach out to me on LinkedIn. I can talk about that contracts all day. Um, I love hearing from you and your particular challenges and how this might help. So do feel free to reach out. I'd love to hear from you.